Hello everyone, my name is Lahari Vilasagar. I am from Sri Siddheshwar Women's College of Engineering, Solapur, and today I am going to explain the topic Syntax Directed Translation or SDT for procedure calls from the subject Compiler Design. In this presentation, we will understand how compilers use semantic rules and grammar to handle procedure or function calls during program execution. Before understanding SDT, let us quickly revise compiler design. A compiler converts high-level programming code into machine-level code. This process happens in different phases like lexical analysis, syntax analysis, semantic analysis, and code generation. Syntax direct translation or SDT is a method where semantic actions are attached directly to grammar rules. These semantic actions helps the compiler generate intermediate code and check semantic correctness during parsing. In simple words, SDT connects the syntax of a program with its meaning. Now, let us understand procedure calls. A procedure call happens when one function or a procedure calls another function in a program. For example, if we write sum of a comma b, the compiler must evaluate the arguments, store them properly, transfer control to the called function, and finally return the result. In the SDT scheme for procedure calls, there are four important steps. First, the compiler evaluates all the arguments passed to the function. Second, it creates an activation record or a stack frame to store parameters and local variables. Third, control is transferred to the called procedure. Finally, after execution, the result is returned and the previous state of the caller is restored. Now let us quickly talk about semantic rules and attributes. In SDT, attributes carry information during parsing. There are two types of attributes: synthesized attributes and inherited attributes. Synthesized attributes move information from child node to parent node. Inherited attributes pass information from parent nodes to child nodes. These attributes helps the compiler generate correct intermediate code for procedure calls. Next is parameter passing. There are mainly two types of parameter passing methods. The first is call by value, where copy of arguments is passed to the function. The second is call by reference, where the address of the variable is passed. The compiler must handle both mechanisms correctly during the function calls. An activation record, also called a stack frame, is a memory structure used during procedure calls. It stores return address, actual parameters, local variables, temporary values, and saved registers. Whenever a function is called, a new activation record is pushed onto the stack. Let us see examples. Suppose we have this statement result is equals to add of a comma b. The compiler first generates parameter instructions param a, param b, then it generates call add comma 2. Finally, the return value is assigned to the result. The generated code is called 3 address code, and SDT helps provide it step by step. Now let us discuss some advantages of SDT. It provides systematic translation based on a grammar. It supports recursive and nested procedure calls. It simplifies intermediate code generation. It improves compiler efficiency and maintainability. Because of these advantages, SDT is widely used in modern compiler construction. Although SDT is powerful, it also has some challenges. Handling inherited attributes can become complex. Managing symbol table and scope is difficult in large programs. So, proper design is important while implementation of SDT. Thank you.